There's a common misconception that nuclear power plants are slow and expensive to build, but actually this is not a technological problem. It's a political one. There are two case studies that might change your mind. The first is the Baraka nuclear power plant in the UAE. It's made up of 4 APR 1400 reactors and is now fully operational. Together, these reactors supply up to 25% of the nation's electricity needs, preventing over 22.4 million metric tons of carbon emissions every year. What's really remarkable about this case study is that the UAE went from having no nuclear industry and very little nuclear expertise to having 4 working reactors in roughly a decade. How did they do it? With a little help from South Korea. Newly built South Korean nuclear power plants achieve speed and cost effectiveness in construction that exceeds most other countries. Also, the decline in South Korean nuclear power costs is comparable to the decline in solar power costs in Germany over the same period. And building nuclear power plants in China is also 7 or 8 times cheaper than anywhere else. So what's going on in the West, and why can't we do the same as South Korea and the UAE and other countries? Regulatory barriers. Of course, some regulation is necessary with any technology, but there's a valid argument that nuclear construction regulations across the West have become overly cumbersome because of overzealous concerns with safety and environmental standards. In Britain, we are building Hinkley Point C and Sizewell C, using the European Pressurised Reactor or EPR design. This is a 3rd generation pressurised water reactor developed in France. Hinkley Point C is located in Somerset and it's expected to generate about 3.2 gigawatts of electricity from its 2 reactors once completed. It will be the UK's first nuclear power station in over 30 years and is expected to provide 7% of the UK's electricity needs, powering around 6 million homes. Hinkley Point C has faced numerous delays, but that learning should translate to building Sizewell C and help to bring down cost and build time. A small but persistent anti-nuclear campaign group in Britain has been protesting Sizewell C for years. Last year, they lost a legal challenge against the energy provider EDF Energy. The anti-nuclear group argued that putting a new reactor at the existing power plant site is not ecologically sound. But the environmental statement that the Sizewell C team had already put together to address this in 2020 clearly demonstrates that the site will have a net gain for biodiversity, which is necessary for project approval in the first place. EDF's environmental plan also involves building a new 11-acre marsh wetland habitat for wildlife, amongst other things. Now, a year after they launched the legal challenge, a judge dismissed it, stating that the anti-nuclear group's arguments were totally without merit. But for the anti-nuclear group, the year of stalling and required paperwork, a 2-day hearing, and now an ongoing appeal amount to a victory. Because of stunts like this, despite cross-party and public support for nuclear energy in the UK, it's very difficult to get new infrastructure projects off the ground effectively, and then people lose hope in the technology when they see constant delays without necessarily knowing what has caused them. This has led to the widely believed myth that nuclear power plants are inherently slow to build. Meanwhile, South Korea's APR 1400 reactors are highly reliable and efficient, but if they wanted to build a nuclear reactor in Britain, it would take much longer for them than it does at home. The company would have to get approval through multiple bodies and the Environment Agency. They would assess the design for safety, environmental impact and waste management, which would already take around 4 years. Then the company would have to apply for planning permission. And then the application would have to be approved by the local council, which means having the support of local residents and regional politicians. These bottlenecks are preventing us from using this life-saving technology. Mounds of paperwork and constraints required by the regulatory process are turning off investors in droves. In 2019, the Japanese company GE Hitachi lost £2 billion after failing to secure the necessary government commitment to build a new reactor at the Wesr site in Wales, and they ultimately gave up on the project. The greatest irony is that the standards for nuclear builds are stricter than those for building coal-fired power stations, and this is all in the name of safety and environmental standards. The new reactors under construction in the UK are French EPRs, but they only gained approval in the UK after being altered, which means that we made thousands of changes to the reactor design. People like to blame the EPR, but to meet the requirements, the original design would need 7,000 changes, including 35% more steel and 25% more concrete. So the cost goes up because of the need to source and pay for extra materials, which are not needed for those reactors to function well in France. And it also means that the lessons that EDF's engineers have learned about reactor design can't easily be applied to the UK. A simple question here is to ask why reactors that are approved in other countries have to go through our approval processes in the first place. If they are safe abroad and the EPR has functioned safely in France for decades with no problems, then why can't they automatically be approved in Britain? South Korea's APR 1400 reactor has already been approved as safe in the US and parts of the EU. Equally, medicines that are recognised as safe in the US, EU and Japan are automatically approved as safe in the UK. We don't test them according to our standards, as we trust this has happened already overseas. Why not apply the same approach to nuclear reactors? If we were to automatically approve designs, this would shorten the time that it would take to bring, for example, a South Korean reactor to market, and it would also avoid the unnecessary design changes and additional cost and build times. We need to leave building large infrastructure projects to engineers, not lawyers. Countries in the West need to re-regulate nuclear power to build them quickly and at cost. Of course, we're thinking about safety, but when we look at risk assessment, we should also consider the risk of not building them. In this case, increased greenhouse gas emissions and air pollution through continued reliance on burning fossil fuels because we can't build clean energy. This brings us to the next point, standardization. When considering advanced nuclear reactors or small modular reactors, innovation is really important. But when it comes to regular nuclear, it's best not to change the design. Actually, it's best to build the design like a Lego set, exactly the same reactor design over and over again. This method of learning by doing has actually been shown to lower cost and build time. Making design changes disrupts that process of standardization, which leads to more delays, as a reactor is essentially being built from scratch in an amended way from the original fleet in, for example, France. That's a real problem because productivity gains come from practice. One of the reasons that South Korea's costs are low compared to the UK is because they build fleets of reactors rather than one at a time. This is known as a standardization model. Every time they build a reactor, they learn something new and can apply it to future projects. The same team builds the same reactor repeatedly, which means they get better and faster at it. Between 1970 and the year 2000, France built 58 nuclear reactors at an average of 2.6 years faster than US plants, which was partly due to a high degree of standardization. Next, we have skills deficit. Nuclear energy creates about 25% more employment per unit of electricity than wind power, while workers in the nuclear industry earn 1/3 more than those in the renewable sector. These jobs are well paid, long-term and predominantly local. They are also unionised. A report by the British Science Association assessing insights into young people's attitudes towards nuclear energy found that young people in Britain are open to careers in the nuclear sector, but they don't feel they're informed about it. The research showed that 14 to 18-year-olds felt more informed about renewables and fossil fuels than nuclear energy, including through schooling. Young people are also highly concerned about climate change and want to learn more about how nuclear energy could help to address it. This seems like a simple fix to actually teach kids in school about clean energy and nuclear energy in particular. They can't be part of something they don't know about. So we actually know how to bring down costs and build time, which are closely related when it comes to nuclear power plants. The changes might seem complicated, but actually they're very simple. These are not technological changes, they're policy changes. Pick a good design, remove cumbersome regulatory barriers, inform and incentivize workers, and then build fleets at a time. It's not rocket science. Nuclear energy is at the forefront of the fight for clean air, energy security, climate change, and the decarbonisation of electricity grids. Many Western countries have overcomplicated the process of building large infrastructure projects that are needed to protect and advance civilization. The future of energy abundance and resilience is up for grabs if we choose to permit it.